Assalamu alaikum, my dear student. How are you? Hope you are well. This is Mohammad Ashraful Islam, lecturer, Department of Physics, Milestone College. Today I am here taking an online class. I hope this class will help you the better study at your home. Today I am going to discuss chapter 7 from your first paper, and the topic of our today's discussion is structural properties of matter. Before starting the mathematical problem, let's see all the formula that I have discussed in my class. The first formula from strain. The first formula for longitudinal strain, and the formula is small l by capital L. Here capital L is the initial length and small l is the change in length. Next formula, the shearing strain. The formula of shearing strain is tan theta equals to small d divided by capital D. Small d is the displacement between two surfaces and d is the height of the body. And third formula for volume strain, and the formula of volume strain is small v divided by capital V. Here capital V is the initial volume and small v is the change in volume. Now formula number 4, the formula is stress equals to F by A. Here F is the force and A is the area. Now formula of Young's modulus, the formula number 5, the formula is Y equals to capital F capital L divided by small l divided by capital A. Now the formula of rigidity modulus. The formula of rigidity modulus is N equals to F divided by theta into A. Here F is the force, A is the area and theta is the shearing strain. Now the last formula, the formula is volume or bulk modulus. The formula is K equals to capital F into capital V divided by small v divided by A. Next formula, the formula for work done. The formula is W equals to YA small l square divided by capital L. And the work done for unit volume is W equals to half into Y small l divided by capital letter L into small l by capital letter L. And in another word, we can write the formula of work done per unit volume is W equals to half into stress and strain. Next formula, Poisson's ratio, and the formula is sigma equals to minus del R divided by del L into L divided by R. Here we use minus sign because del R is opposite to the del L. The next formula for viscous force, and the formula is F equals to eta A del V divided by del Y. Here F is the viscous force, eta is the coefficient of viscosity, A is the area and dV by dy is the velocity gradient. Next, Stokes law. From Stokes law we will get a formula of viscous force which is F equals to 6 pi eta R into V. Here eta is the coefficient of viscosity, R is the radius of the sphere and small v is the terminal velocity. The next formula to calculate the terminal velocity, and the formula is V equals to 2R square divided by 9 eta into rho s minus rho l into g. Here R is the radius of the sphere, eta is the coefficient of viscosity, rho s is the density of the solid, rho l is the density of the liquid. Next formula for surface tension, and the formula is T equals to F divided by small l. Here capital F is the force and small l is the length. In case of the needle and water, when we raise the needle or water from the water surface. In that case, the formula of surface tension will be T equals to F divided by 2L. And now the relation between surface tension and the surface energy is E equals to T. The final formula which is related to the contact angle or angle of contact, and the formula is T equals to HR rho into G divided by 2 cos theta. Here theta is the angle of contact, R is the radius of the capillary tube, S is the height of the capillary tube, and rho is the density of the liquid. This all formula related to the chapter structural properties of matter. I hope this formula will help you to solve your mathematical problem and MCQ question also. So let's see the important unit and dimension regarding this chapter. The first quantity is stress. The unit of stress is Newton per meter square, and we also called the unit of stress is Pascal, and the dimension of the stress is M L inverse T inverse 2. There are no unit and dimension of strain because it's the ratio of same quantity. Now the unit and dimension of modulus of elasticity. The unit of the modulus of elasticity as same as stress because is the ratio of stress and strain. As there is no unit of strain, so the unit of stress will be the unit of modulus of elasticity. That is why the unit of modulus of elasticity will be Newton per meter square or Pascal, and the dimension is also same to the stress, and the dimension of modulus of elasticity is M L inverse T inverse 2. Now the unit and dimension of coefficient of viscosity. This is very, very important. The unit of the coefficient of viscosity eta is Newton second per meter square. In another word, we can write Pascal second, and there is another unit of eta which is kg per second per meter. Another unit of the coefficient of viscosity is poise, and there is a relation between the poise and Newton second per meter square. That is 10 poise equals to 1 Newton second per meter square. And the dimension of the coefficient of viscosity is M L inverse T inverse 1. Now the unit and the dimension of surface tension. First, unit of the surface tension is Newton per meter, and the dimension of the surface tension is M per T square. This all the unit and dimension that we have in the chapter structural properties of matter. I hope this unit and the dimension will help you in your MCQ exam. Okay, let's start our today's lecture. First MCQ question. Let's see the question. The question is, what is the value of angle of contact for which the glass does not wet? The answer of the question is the contact angle will be more than 90 degrees. So our answer is the contact angle will be more than 90 degrees. Next question, question number 2. The question is, by applying the force in a wire having length 1 meter and the diameter 1 millimeter, the length is increased by 0.025 centimeter, and the question is, what is the decreasing diameter? Here the given information sigma is 0.1. Sigma means Poisson ratio, and this question was appeared Joshua Board 2019. Let's solve the question. You know the formula of Poisson's ratio is sigma equals to del D divided by del L into capital L, that is initial length divided by diameter. And we have to calculate the value of increasing diameter, that is del D. So we can write the equation del D equals to sigma into del L into D divided by capital L. Now if we put the all values, then we can write sigma is here 0.1 into del L increasing length is given 0.025 centimeter, and if you convert centimeter to meter, then you can write 0.025 into 10 to the power minus 3. And here D is the diameter, and the diameter of the wire is given 1 millimeter. 1 millimeter means 10 to the power inverse 3 meter divided by capital L is the initial length, whose value is given here 1 meter. Now if we calculate the expression, we will get the result of del L, that is decreasing diameter is 2.5 into 10 to the power minus 5, and its unit will be millimeter. This is the answer of question number 2. Now let's see the question number 3. The question is, if a wire is divided into 2 equal pieces, what will be the breaking weight? You know, the breaking weight depends on the nature of the material. If we divide the wire in the 2 pieces, then size of the wire will be equal, or will be half. But the breaking weight doesn't depend on the size of the material, it depends on the nature of the material. So our answer will be remain same, because it does not depends on the size or the length of the material. Now question number 4, the question is, what is the formula of a viscous force? You know, from Stokes' law, viscous force is proportional to the coefficient of viscosity eta. Viscous force F is proportional to the radius of the sphere, and the viscous force is proportional to the terminal velocity. And after combine these 3 equations, we will get the final formula of viscous force, which is F equals to 6 eta R V. This is the answer of question number 4. Next question, question number 5. The question is, the breaking stress of a wire depends on the nature of the material. Nature of the material. This is the answer of question number 5. Hope you have understand. Question number 6. The question is, what is the dimension of Young's modulus? We can calculate the dimension of Young's modulus by applying the formula of Young's modulus. We know the formula of Young's modulus is Y equals to F into capital letter L divided by A into small letter L. This is the formula. Now if we put the dimension of force, initial length, area, and the increasing length, then we will get the dimension of Young's modulus. So let's put the dimension of force. You know the dimension of force is M L T inverse 2. Dimension of L, length is capital L, and dimension of A, that is area, is L square, and the dimension of increasing length is also capital L. And after solve this expression, we will get the final result is M L inverse T inverse 2. This is the dimension of Young's modulus. This question is very, very important for your MCQ exam. Next question, question number 7. The question is, for which property of liquid the drop of water made spherical shape? Definitely the answer will be the surface tension. Due to the surface tension, the drop of water made spherical shape. So our answer will be surface tension. Next question is which quantity has no unit? In the given option, the right answer is stress. We know there is a no unit of stress because stress is the ratio of same quantity. So stress has no unit. This question was appeared Chittagong Board 2019. Next question number 9. The question says, by applying pressure of 10 to the power 5 Newton per meter square in a where the length of 1 meter and increasing length will be 0.01 meter. The question is, what is the Young's modulus? So, if you want to calculate the Young's modulus, the formula will be F equals to stress divided by strain, because we know Young's modulus is the ratio of stress and strain. The formula of stress is F by A and the formula of strain is small l by capital L. Now, you can write F by A is the pressure, and if we solve this equation, we can write here F into L divided by A into L. Here F by A is the pressure and whose value is given here 10 to the power 5. Small l is the increasing length whose value is given 0.01 and the capital L is the initial length whose value is given here 1 meter. Now if we put the value, so we can write 10 to the power 5 which is the pressure and initial length is 1, increasing length will be 0.01, and after calculation that expression we will get the result 10 to the power 7 and its unit will be Newton per meter square. This is the answer of the question number 9. Now the question number 10. The question is, if the surface tension is 0.06 Newton per meter, then what will be the surface energy? You know the surface tension always be equals to the surface energy. So the formula of surface tension and the surface energy is like that, E equals to T. E equals to T. Surface energy is represented by E and the surface tension is represented by T, which is equal. So we can write here the given information surface tension is 0.06 Newton per meter. That is why the surface energy also equals to 0.06 Newton per meter. This is the answer of question number 10. Hope you have understand. Question number 11. Let's have a look. The question number 11. The question is, what is the dimension of coefficient of viscosity? This question was appeared Joshore Board 2019, Rajshahi Board 2017 and 15, Borishal Board 2017. So this question is very important. So let's see the dimension of coefficient of viscosity. You know the formula of force F, that is visco force F equals to eta A d V divided by dy. By this formula, if you want to calculate the dimension of coefficient of viscosity, that is why we can write coefficient of viscosity eta equals to F into dy divided by A into dV. Now if we put the dimension of force, displacement, area and velocity, then we will calculate or we will get the coefficient of dimension of coefficient of viscosity. Let's put the dimension of force. You know dimension of force is m, l, t inverse 2. dy is the displacement. A dimension of the displacement is L. Dimension of area is L square into dimension of velocity. dv is the velocity and dimension of the velocity is L t inverse 1. And after calculation that expression, you will get the dimension of coefficient of viscosity is m, L inverse T inverse 1. This is the answer of question number 11. Hope you have understand. Next question, the question is, what is the another name of the volume modulus? This question was appeared Borishal board 2019 and the Dhaka board 2017. You know the volume modulus is the opposite name of bulk modulus. So the answer is bulk modulus. Next question, question number 13. The question is, if the cross-sectional area of a wire is 1 millimeter square and the cross-sectional area of a wire is 40 kg, then what will be the breaking stress? You know the formula of the breaking stress. The formula of breaking stress is breaking weight divided by area. Breaking weight area. And you can calculate the weight by using the formula W equal to mg. So our formula will be mg divided by a. Here mass is given 40, g is acceleration due to gravity and whose value is 9.8. Area is given 1 millimeter square. 1 millimeter square equals to 1 into 10 to the power minus 6 meter square. So if you put the value of mass, which is given here 40, g is 9.8 divided by area is here 1 into 10 to the power minus 6. And after calculation that expression, we will get 3.92 into 10 to the power minus 8. The unit will be Newton per meter square. This is the answer of question number 13. Hope you have understand. Now question number 14. The question is, if the lateral strain of a wire is 0.002 and the longitudinal strain is 0.02 meter, then what will be the Poisson's ratio? You know the formula of Poisson's. Now here I put the value. Longitudinal strain is here 0.02 and lateral strain is here 0.002. 0.002 divided by 0.02, and after calculation 0.1, and it has no unit because this is the ratio of same quantity, that is strain. Now question number 15. The question is, what is the relation between the surface tension and the surface energy? This question was appeared Rajshahi board 2016. And the relation between surface tension and the surface energy is equal. That is, we can write, if the surface energy is E and the surface tension is represented by T, so the formula or the relation between surface tension and surface energy is E equal to T. This is the answer. Hope you have understand. Next question, question number 16. The question is, in which state the intermolecular attraction force is more? This question was appeared Joshua board 2016. And the intermolecular force is more in a solid state, because in solid state the intermolecular gap is less, That is why intermolecular attraction force will be more. So our answer will be solid. And if you ask the question, intermolecular attraction force is less in which state, the answer will be the gaseous state, because in gaseous state the intermolecular gap between the molecules is more. That is why here attraction or intermolecular attraction is less. Hope you have understand. Next question, the question is a wire of length 0.5 meter can be raised from the surface of water by applying maximum 72.8 into 10 to the power minus 3 Newton. The question is, what is the surface tension of the water? You know the formula of surface tension, T equals to F divided by L. But in case of the needle of or a wire, when we take or raise the wire or the needle from the surface of water, then in the both side of the needle the force, that is tangential force, will act. So we write here the formula of surface tension, T equals to F divided by 2L. Here F is the force whose value is given 72.8 into 10 to the power minus 3 Newton, and L is the length of the wire whose value is given here 0.5 meter. Now if we put the value of F and 2 into 0.5, and after calculation that expression we will get the result 72.8 into 10 to the power minus 3. This is the answer, and its unit will be Newton per meter. This is the unit of surface tension. Now question number 8. The question is, if the density of solid is rho s and the density of the liquid is rho l and the angle of contact is theta, then what is the relation between them? If the density of the solid, that is, we can write density of solid is greater than density of liquid, in that situation the angle of contact will be less than 90 degree. Theta will be less than 90 degree. Now if we consider the density of the liquid is more than the density of the solid, then we can write density of the liquid is more than the density of the solid. In that situation the angle of contact will be more than 90 degree, that is theta will be greater than 90 degree. So this is the relation between density of solid, liquid and the angle of contact. The next question is, where is the reciprocal quantity of the bulk modulus? The reciprocal quantity of the bulk modulus is compressibility. This is the knowledge based question and you have to memorize this question. So our answer will be compressibility. Now next question, question number 20. The question is, the work done to increase the area of a liquid after 1 unit is called what? Is called the surface tension. So the answer is surface tension. Let's see the question number 21. Question is, how much force is to be applied of a steel wire of cross-sectional area 1 millimeter square and length 1 meter to increase length by 10%. That means to increase the length 10% of a wire having length 1 meter and cross-sectional area 1 millimeter square, how much force should be applied? We have to solve this question by applying the formula of Young's modulus. You know the formula of Young's modulus is y equals to F L divided by capital A and small l. Here we have to calculate the force. That is why we can write F equals to y A L divided by capital letter L. Here increasing length will be 10%, that means 0.1. Increasing length is here small letter L. Now if we put the value y is 2 into 10 to the power 11, which value is constant for where A is cross sectional area and which value is given here 1 millimeter square. 1 millimeter square means 1 into 10 to the power minus 6, and increasing length is here 10% of the initial length, that is 10% of 1, and it will be 0.1 divided by the initial length is here 1, and after calculation that expression we will get the result 10 to the power 2 into 10 to the power 4, and its unit will be Newton. This is the answer of question number 21. Hope you have understand. Next question, the question is Hooke's law within elastic limit. The statement of the Hooke's law is within elastic limit the stress is proportional to the strain. That is why we can write stress proportional strain. Next question, question number 23. The question is if an angle of contact is more than 90 degree, then the water surface will be convex. Next question, question number 24, and the question is within elastic limit the ratio of shearing stress and shearing strain is called what? You know the definition of the rigidity modulus is within elastic limit the ratio of shearing stress and the shearing strain is called rigidity modulus. This question was appeared Dhaka Board 2015. So the answer will be rigidity modulus. Rigidity modulus. Next question, question number 25. This question was appeared Borishal Board 2019, and the question is where is the unit of surface tension? The unit of surface tension is Newton per meter. Let's see the unit of surface tension. The formula of surface tension is T equals to force divided by length, F divided by L. Now if you put the unit of force and the length, then you will get the unit of surface tension. You know the unit of force is Newton and the unit of length is meter. And after combining this expression, we can write the unit Newton per meter. This is the unit of surface tension. Hope you have understand. Next question, this is the last question of my today's discussion, and the question is if some detergent mixed with water then its surface tension will be definitely the surface tension of the water will be decreased. So answer will be decreased. That's all for today. If you have any problem in my today's lecture that I have discussed in my class, so you may ask your subject teacher. Thank you for your patient hearing. Stay safe, stay home.